research and practitioner from intellectual exchange, collaboration, and dissemination of cutting-edge advancement in the domain of sports science and or other related fields. On behalf of Dean of Faculty of Sports Science and Health, I would like to extend our sincere gratitude to two wonderful keynote speakers from Ajmol Ali from School of Sport, Exercise and Nutrition, Massey University, New Zealand. Assalamualaikum, Prof. Ajmol. Yeah. And Dr. Ayu Suzailiana Muhamad from School of Health Science, University Sains, Malaysia. Also, allow me to express my gratitude to the participants, students, and lecturers from various departments with Universitas Negeri Makassar and other universities who are enthusiastic in attending this precious event. Finally, I would also like to invite all participants to express our appreciation to the chair of webinar committee and all members of organizing committee for their hard work in making this international webinar series a success. I wish all of you a productive and reward discussion in this webinar. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Shahrudin Enkas, for the opening remarks and also officially opening this event this morning. I think we can just proceed to the next schedule, which is the first keynote session with Professor Ajmol Ali from Massey University. Can you hear me, Aj? Can you hear us? It's great. Okay. Before I give a chance to Professor Ajmol Ali to deliver his keynote presentations, please allow me to introduce him to the participants by reading his short biography. So Professor Ajmol Ali is a professor of exercise science at School of Sport, Exercise and Nutrition in Massey University, New Zealand. Ajmol started at Massey University in 2003 and is currently a full professor in the School of Sport, Exercise and Nutrition at Albany, Auckland campus. Ajmol was instrumental in setting up the Sport and Exercise Science Laboratory at Auckland, supervised a number of Ph.D. and MSc students, and is also involved in various promotional and consultancy initiatives on behalf of the School of Sport, Exercise and Nutrition and Massey University. Professor Ajmol Ali is also the International Director for College of Health, and he is also a former Deputy Chair of the Massey University Human Ethics Committee, Director of the Center for Metabolic Health Research, and Director of Beverage Lab. He has done various and a number of publications in the peer review leading international journals such as in Nutrients journals, European Journal of Nutrition, and International Journal of Primary, Elementary, and Early Years Education, and also Science and Sports journals. So without further ado, please let us welcome Professor Ajmol Ali for delivering his keynote presentation. Please, Prof. Aj. Oh, you're still in mute, sorry. We check. You can unmute, yeah.
Okay, Thank you. Assalamu alaikum. And Professor Sairuddin, thank you for that welcome. Thank you, Bastang, for that welcome as well. So I really appreciate the time and the opportunity to speak with you again. I've been to Makassar 2 times now, and I've really enjoyed my time. And this time I'm presenting to you while still in my office here in New Zealand. I'd just like to share my screen now. Oh, can you allow me to share, Bastang, please?
Yeah, sure. Let me find out. Yeah.
Is that okay? No, it's still disabled.
Well, we try to allow you to share screen.
Mm-hmm. Okay. So while I'm waiting, and if you can just see what you can do there, Bastang, I'll just introduce myself.
Sure,
Thank
sure.
you for that, Bastang. I was actually born in Bangladesh, and I grew up in the UK, and I've been here in New Zealand for the last 20 or so years now, and I've really enjoyed my role here at Massey University. I get to travel around to different parts of the world, which is really exciting. I get to speak to people. I get to interact and engage with other academics from around the world, and I've loved my time in Indonesia and Malaysia and other countries in that area. And it's really nice, very welcoming and very hospitable for you guys to have me here again. Now, Bastang, how are we doing on that sharing?
We still try to find out to put you as a co-host so that you can share your screen.
Okay.
Yeah.
Right.
Yeah. Just maybe you can just have a chat at the moment, just to. I would like
I'm good to go.
Oh, yeah, it's okay. It's happening now.
So can you see my main screen?
Yes.
You can see the presentation.
Yeah. Yes.
You see the
we can
presentation
see
slides.
the flyers. What we see now is the flyer of the event. Yes.
Yeah.
Yeah. Please, you can now start.
You can see the main screen.
Yes. Yes, it's working.
Okay.
It's working.
Okay.
It's working.
Excellent. Thank you very much. So when I spoke to Bastang, I've spoken a couple of times about some of the research I've done in New Zealand. And what I wanted to do was just to share with you some of the work I've done in soccer performance, in football performance, and supplementation research in this space. So I'll just give you a brief background and hopefully allow some time for questions at the end. Now, as I said, I was born in Bangladesh, and that's me. That's the village I was born in. That's the actual school that I went to, and it's the school on the left-hand side. That's my old school over there. This is the newer version of that primary school, and that's where I started my journey in the academic world. I grew up in the UK, and I went to Loughborough University, same as Bastang. At different times, we went to Loughborough University in England, and now I'm here at Massey University here in Auckland. I've got a very short video clip I'd like to share with you. Can you see the video clip, Bastang? Just give me a thumbs up if you can. Yeah, okay. So this is our Manawatu campus, our main campus. We've got 3 campuses around New Zealand. This is our biggest campus. It's a very green campus. It's got lots of great facilities there, and we do lots of different types of qualifications, and have very good sporting facilities and gym facilities. And as you can see here, lots of world-class facilities there for athletics, for football, for rugby, for hockey, and other sports like equestrian sport as well. And if anyone is interested in studying here in New Zealand, I'd be very happy to talk to you further around that. I've talked to Bastang about opportunities for Makassar staff or former students or current students. If you are interested, please do contact me. We have 4 campuses. I'm in the Auckland campus. I'm on the north part of New Zealand. Palmerston North is our Manawatu campus. That's the middle one. We also have the Creative Arts and Design campus in Wellington. And because we are like the University of New Zealand, we have a distance course. So people who study via correspondence, by the internet, and we are offering that through all of New Zealand. But recently, We've set up a relationship in Singapore. So we have another campus now in Singapore. So if you do want to study at Massey, there's another option, which is a bit closer to you in Indonesia. We have 5 different colleges. I'm in the College of Health, but we have a large College of Sciences, a large business school, the world-ranked business school, and then our Humanities and Social Sciences and Creative Arts colleges as well. In the College of Health, personally, I am in the School of Sport, Exercise and Nutrition, but we also have the School of Social Work, School of Health Sciences, School of Nursing, and various research centers that allow us and our academics to do lots of world-leading research in various aspects of health, whether it's indigenous health, public health, or sleep-wake research center, for example. So ultimately, we really look at what are the various aspects of health and performance that we can improve with our research, with our teaching, with our graduates, and so on. I'm also, Bustang mentioned, I'm also involved in Beverage Lab. So this is a research collaboration between various colleagues of mine. We have various aspects of the university: food technology, human nutrition and health, and exercise and sports science. We've come together so we can design beverages. We can then do human trials on the beverages, and then we can communicate that and do consumer research. And we're also looking at commercializing our drinks as well. Now, as a result of Beverage Lab, I also set up one project, which is a really big project around various parts of Asia. This is a beetroot juice study to look at reducing blood pressure in older people. So it's a big study, and I'm really looking forward to sharing the findings of that study in the future to people like yourselves. Today, I'm going to be talking about carbohydrate ingestion. This is what I did my PhD on, and I've also done lots of research on caffeine supplementation. I've done work with blackcurrant and beetroot juice and so on. We don't have time to go through all of those things, but maybe I can talk about that another time. I'll start with the carbohydrate supplementation. Some early studies showed that the low level of muscle glycogen in the body reduced the distance covered that athletes covered during a game of football. It reduced their sprinting ability and increased their walking. So if an athlete is walking more and sprinting less, they're not going to be as effective. And there were some initial studies which showed that taking carbohydrate, this is before sports drinks came about, taking carbohydrate led to more goals, and athletes conceded, or the teams conceded, fewer goals. However, there were really big challenges with the experimental control, and there were some issues with ecological validity. Does this actually happen out in the sports field? And so as a result of that, more people started looking at better experimental designs to explore these concepts. At Loughborough University, my supervisor, Kerry Nicholas, and my other supervisor, Clyde Williams, they did several studies in conjunction with Lucozade Sport. For those of you who might have gone to the UK, Bustang, I know, has. Lucozade Sport is the leading sports drink in the UK. I think it might be Gatorade or Powerade or Isostar or something like that in Indonesia. But in the UK, Lucozade, it was a big sports drink manufacturer. Now, we did some work with Lucozade in the early 90s, and this particular study showed that athletes who did a simulation of football, so inside in the lab, but a simulation of football, and then did a performance test at the end, either taking carbohydrate, a sports drink, or a placebo drink with no carbohydrate, just like flavored water. They showed that in the performance test at the end of that 75 minutes of exercise, they improved their performance by 33%. And this was used by Lucozade as part of their big marketing push to really highlight how having appropriate carbohydrate, having a good sports drink with carbohydrate as an energy, with electrolytes to help with water retention and then the water itself, this helped athletes perform better. And in future studies, we also showed that there was more pronounced depletion in type 2 muscle fibers, which are involved for sprinting activity. So if we can get carbohydrate, you get better sprinting and you can run longer as a result of that. One of my other colleagues, Steve McGregor, who worked at various professional football clubs in England, he did some research on the skill performance. And they used the Loughborough dribbling test, LSDT, before and after 90 minutes of conducting this game simulation that represented a game of football. And what they showed was that in the placebo trial, which was obviously no water, no fluid drink, there was a reduction in their performance. The longer they took to do this test, that was a reduction in performance, whereas in the water trial, there was a maintenance of performance. So this was used as evidence to support that athletes should be taking drinks while they're exercising to help with their skill performance, not just their sprinting performance, but also their skill performance as well. Now, this is one of the tests I've just mentioned, the soccer simulation. We've published some work, quite a work using the Loughborough intermittent shuttle running test. And what we did here then is use what happens in a football match to simulate lab running conditions. So we can now say, this is what's happening out in the field. This is what's happening here in the lab situation, which we can control. And that's exactly what that we did with many of our studies. So here on the right-hand side of the graph, it's 90 minutes of run that we do, and in each of those running, in each of these blocks of 15 minutes of activity, they do walking, they do sprinting, they do jogging, and they do running, and do that repeatedly over the course of the 90 minutes. And that's a very commonly used simulation that we use and other people around the world use as well. Ultimately, in football, it's not just about running as well. The skillful aspects of play are very, very important. So we designed various types of skills tests that people at various places around the world now are using, because these are more reliable, more valid, and more sensitive in terms of assessing the effect of a nutritional supplement or water intake or whatever on performance. The performance, as is shown here, on running with the ball, on dribbling, on passing, on controlling the ball, on making decision-making options during the course of this test as well. So we've used this test a lot of the time for the Loughborough soccer passing test. The other test that we use is the Loughborough soccer shooting test. And what this one is like a series of activities that are embedded into a skills test so that players can effectively shoot. They do it at realistic pace, and then they have some other activities which would be relevant in a game of football. So we use these tests as tests of skill, not just a test of technique, to assess the effect of nutritional supplementation or pharmacological supplementation or other types of supplementation on performance. This ultimately is what's very important in a game of football. Using these tests, we've shown, for example, that shooting scale performance, passing test performance is improved with carbohydrate ingestion. We've also shown that sprint performance, you saw that test in the lab, sprint performance is also improved. Now, if you look through these figures here, the blue line is the placebo, the red lines here indicate the carbohydrates. So as you can see, pretty much over the whole 90 minutes, there were faster sprint performance in the carbohydrate trial. So in a nutshell, how can I conclude from my PhD? This is finding from my PhD. Athletes, or footballers in this regard, can sprint to a ball faster. When they get to the ball, they can perform more skillful movements, and they're more likely to score a goal. So that was, in essence, the main findings. At the same time, I'd published some other work which showed they had better metabolic profile. They're also less likely to potentially get injured, and also less likely to have immune function issues because of the carbohydrate dampening their stress responses as well. So lots of good opportunities from having a carbohydrate supplementation. What about the amount of carbohydrate ingestion? Now, ultimately, if you drink too much, then it might give you the tummy upset. If you don't drink enough, then you might not get the effect. So what's the dose-response relationship? We've published some other work which showed that there was no clear dose-response relationship. Some say some might be good, others say, well, a smaller amount might be just as good. There's no clear from that initial study. Others suggest you can't really digest more than 60 grams of carbohydrate per hour. If you start doing too much of that, you'll get gastrointestinal distress in your tummy. You might have to go to the toilet. You might not certainly be able to perform. So is there a minimum amount that we need? Because ultimately, if we can get small amount to an athlete, could they potentially, as a result of that, improve their performance? Not in football, but in another study at Birmingham University, or University of Birmingham, which is near to Loughborough, where Bustang and I went, a very famous researcher called Asker Ukendrup and his colleague David Jones and James Carter, what they did was look at some different ways of bringing carbohydrate into the body. Now, what they did in one study was inject carbohydrate directly into the bloodstream. So instead of saying it needs to go to the mouth, then go into the stomach, then go into the intestines, then get absorbed into the bloodstream, then go round to the muscles, instead of doing that, could we directly inject carbohydrate into the bloodstream? Could that help performance? And they showed actually there was no performance benefit of doing that. They said, well, maybe it needs something actually in that process. We need to actually consume carbohydrate in the mouth before we can carry on getting the ergogenic benefit from them. They did a really nice experiment in the early 2000s, which was a really groundbreaking study at the time. And what they did here was have the carbohydrate. So imagine the drink here. They swilled it around in their mouth. They swilled it like mouth rinse, and then spat it out again. And they did that with carbohydrate drink or a placebo mouthwash. So they did that, spit it out, or with a placebo and spat it out. And what they showed here, and this was the first study that showed this, was an improved performance by 2.9% in the carbohydrate trial. So a 60-minute cycling trial, they showed improved performance. And this improvement happened in all 4 quarters of that performance test. And this is the one that Asker Ukendrup here has designed many years ago now in the mid-90s, and it's one of the most commonly used exercise or time trial tests in the literature. This was quite interesting, very novel, and it caused a lot of interest in various people. And at Loughborough University, I was in New Zealand at this time, and I went to Loughborough and I caught up with Clyde Williams and Ian Rollo and Nick Gant, who was doing the Ph.D. at the time, and since now he is in New Zealand with me. But I was a subject in this study, and what they did was have a treadmill. We had a sensor there. If they ran closer to the treadmill, it sped up. If they ran further away from the treadmill, it slowed down. So we can unconsciously dictate the speed of the treadmill without having to press buttons. And what they wanted to do was to say, unconsciously, does your performance improve or decrease if you take this mouth rinse? And what they showed then, and as I said, I was one of the subjects in this study, this is the time every 5 minutes or so, they gave the mouthwash with a placebo or the carbohydrate. And we see that in the carbohydrate trial, there was a slightly higher or slightly faster, unconscious, slightly faster running speed throughout this 30-minute treadmill run for all athletes, well, for most of the athletes. So in total, what this led to then was this increased self-selected pace, increased distance covered, and higher ratings of pleasure. So you got less pain and more pleasure ratings as a result of this activity. So that was really quite interesting findings. Again, why does this carbohydrate enhance performance even though it's not actually going into the bloodstream at all? And there was some really nice data from the US, out of Florida, University of Florida, I think it was. And this was published in Nature, one of the leading journals in the world. And what these guys here then did, looked at the temporal response of the brain after eating following functional MRI, so fMRI. And what they showed then was that immediately after taking this carbohydrate, there was a response in this part of the brain. And then 10 minutes later, when the body absorbed, assimilated, digested, and then put it into the bloodstream, and then it went into the brain again. We have the same response 10 minutes later. However, in the placebo trial, there is no response. And what you can see here in 18 subjects, the same thing happened. So this initial response in the mouth, and then the delayed response later on. But what we think then is that as soon as we take carbohydrate into the mouth, these receptors in the tongue, via the cranial nerves, they create more blood flow into certain parts of the brain, and this gives a more positive response in the motor control area, plus also the reward centers of the brain. And what we believe, and the way I best explain this, is like saying there is an overdraft. The body, or the mind, knows that the body will receive carbohydrate in 10 minutes time, so therefore it gives it a bit of an overdraft. It gives it the opportunity to work a bit harder, knowing that in 10 minutes time that glucose will be available for the brain. Now, as you know, the brain's fuel, main fuel, is carbohydrate. 80% of the fuel that the brain uses is carbohydrate, small amounts from fat and protein and alcohol and so on, but 80% is from carbohydrate. So if we can provide that carbohydrate, could that help with the performance? So I wanted to explore this further. And I was like, I'm still a bit unsure about whether this works or not, because I wanted to test it here in my lab myself. So what I did initially a cycling trial. I wanted to explore this in a cycling format before I went into the football side of things, because from a football side of things, if you think an athlete is playing a lot of football, it might not able to have as much drink as we want them to do, because their blood is everywhere, not in their tummy. The blood is everywhere. So if you can just, swill around the carbohydrate and spit it out, could that give them performance benefits? But before I went to football, I wanted to see what was the effect in a cycling study in my lab. And I had four study groups. And this is like what we call a Latin square design. So I had a placebo rinse and a carbohydrate rinse. And then I had a placebo ingestion, so they're just drinking water, and then a carbohydrate ingestion. So here, this one, placebo rinse, there's no water, no carbohydrate. Here, there's no water and just carbohydrate rinse. Here, it's just water ingestion, no carbohydrate. And here, it's the actual carbohydrate that goes into the body, into the bloodstream, and also the water that goes in as well. So it's a Latin square design that I explored. And we wrote a few papers from this at the time. And as you can see here, we expect in the carbohydrate rinsing trial, if that signal that carbohydrate is on your mouth allows your brain to get this overdraft facility, then in a carbohydrate rinse thing, we should see a really good effect. But it didn't. Unfortunately, it did not show that. So we can see here in the placebo rinse, the carbohydrate rinse, and just the water ingestion, there was no change in performance. However, in the carbohydrate ingestion trial, about 5% better than the other trial. And it's quite a decent effect size, of 0.57 to 0.65. So the carbohydrate ingestion in these really challenging times, long periods of exercise we were asking them to do, we showed that it was the ingestion that was important. And when we look at the work rate across that 60 minutes of cycling, we see that the carbohydrate ingestion trial has pretty much higher work rate for most of the trial, especially towards the second part of the trial. Now, I have not done this experiment further in football, but one day I hope to be able to do this, but I just have not had the time or the funding to be able to do that. So that's something I am very much looking forward to doing in the future. Could rinsing protocol potentially help in a real life environment in a football field? Other research I've done is with children. Now, children, as we know, and this is for those of you who know, this is from Austin Powers. We've got Mini-Me here, and that's the main character. And what we're trying to say is children are not miniature adults. Why is that? Because their sweat rates are much lower. Their sweat glands are not as well developed. Therefore, they can't sweat as much. They have reduced electrolyte loss relative to adults. They're also have much lower reliance on, much lower reliance on muscle glycogen because they have reduced glycolytic enzymes, and also a higher reliance on fat as a substrate. And they have increased heat loss, not evaporation heat loss, but dry heat loss. So they're more likely, because of their higher surface area to mass ratio, they can gain and lose heat more quickly. So all in all, do children need sports drinks? That's the question we ask. You see children who are drinking sports drinks on a football field in different parts of the world, here in New Zealand as well. Do they actually need it? We wanted to do some experiments here in this space as well. Now, the evidence for whether children should take carbohydrate is far less than in adults. Some studies have shown a slight benefit in younger children. That Riddle et al. Study, they showed in 10 to 14-year-olds for 90 minutes while consuming either water or a 6% carbohydrate drink or a 3% glucose and 3% fructose solution, there was an improved performance with the 6% carbohydrate solution. So some studies have shown that. Other studies have shown no difference on RPE during a 60-minute cycling test following carbohydrate ingestion. Some have shown improvement in intermittent exercise capacity. However, the key thing to understand is that because of this limited research, we cannot just take the research from adults and apply it for children. We have to look at specifically for children based on the physiology, based on the requirements of their sport, and so on. And I did have a Ph.D. student who started with me from Malaysia, and we looked at the picture of the children in Malaysia doing some of the football testing. We did do some research in here, but it didn't quite finish, unfortunately. So I am very keen on doing this research in the future too. Other studies that we're looking at are things like the drinking habits of children. And we recently finished a study with 13 or 1,400 junior athletes from 10 to 13 years old. And we asked them, using a questionnaire, an online questionnaire, what were they drinking before? What did they drink during, and what do they drink after exercise? And we set up this sort of stand, and we have iPads set up like this before, after, and during the sport. They come in and let us know what they did. So it was a really nice study there, and I'll be publishing that work very soon once I can find some time to write the papers up. Other things that we're looking at are consumer research. The taste profile of drinks can change as we exercise. So we've published some really nice work in this area. And what we've shown is that as people become more dehydrated, as people start losing carbohydrate, then the sensation of sweetness and saltiness that you just taste of the same drink changes. And we've done some work with the cycling type environment. I'm looking forward to exploring these things in the future with children as well as adults as well. Now, in the interest of time, I have not shown you the information on women's football. So I've done some research on women's football as well in terms of thermoregulation, in terms of caffeine intake and water intake and skill performance and so on. But in terms of carbohydrate ingestion for soccer, carbohydrate can help with maintaining endurance performance over 90 minutes. It can help maintain higher sprint performance over the 90 minutes. It can also help maintain better skill performance. And while that's happening, it can also reduce the risk of injury and reduce the inflammatory response as well. So they're all really good things. And that's why we should recommend, for adults at least, adult males, we should recommend a carbohydrate or sports drink, small amounts for them to help their performance. The carbohydrate ingestion increases high work rate and provides a better metabolic profile. It also helps with the feel-good response. If you feel better, you're more likely to perform better as well. And I've shown in several of my research studies that that's the case as well. So that's the carbohydrate story. When I first came to New Zealand, I don't drink caffeine myself. I don't drink coffee myself, but I've done a lot of research in this space. And I came to New Zealand, and there's a very, very famous rugby player called George Gregan. He was the scrum half and captain for Australia. And he said this in the newspaper. He said, we take a lot of things to get those little extra 1%ers. You can get 7% extra work output from taking these caffeine tablets, a big increase at this end of the sport. So I wanted to explore this further, and I did some research with caffeine. I'm going to share with you some of the findings here. There was a really big study done by Juan Del Coso et al. In 2011. And what they did was collect the urine samples from 21,000 athletes between 2004, 2008. So 2004, the Olympic Games was in Greece, and then 2008 was in Beijing. In between that time, they sampled a lot of athletes. And what they showed was that 0.6%, only a small percent, exceeded the safe limits, or the limits that WADA, the World Anti-Drug Agency, wanted athletes to consume no more than. So very, very small number of them would have actually failed the drug test. Most of them would have been perfectly fine. 3/4, so 3 out of 4 athletes, consume caffeine before during competition. It's one of the most widely used ergogenic aids in the world. And 19% also used it with other substances. Now, why do you use caffeine with other substances? It's because caffeine has an adjuvant effect. What that means is that it can help speed up some pathways, and it can slow down other pathways. So hence, it's part of pre-workout supplements, or it can be taken with painkillers. It can be taken with performance-enhancing drugs as well. So caffeine is quite commonly used in that regard. There was also higher use with endurance athletes and higher use with older athletes, according to this quite large study. Now, our studies that we've done in this space show that caffeine can help with performance. It can help with jump performance. It's helped with skill performance, as we've shown in here, and it can also help with a sprint performance as well. So jump performance, skill performance, and sprint performance. Very important aspects of a soccer player. So if caffeine can do this, and we've shown the data here, why should it not be added into a drink? And as a result of some of this work, you can probably just see, just in the top right corner, the Lucozade Sport guys, they developed a drink called Caffeine Boost. And we did some of the research in this space. And I'll tell you about that in a second. Now, what our research shows that there are independent and additive effects of caffeine and carbohydrate ingestion. Caffeine helps, carbohydrate helps. Both of them help even more. And the reason why we say that, a study by Greg Koch et al. And others in Australia, at the Australian Institute of Sport, they noticed that their athletes take a can of Coca-Cola, open the can of Coca-Cola, let all the fizz, the carbon go out, and then they drink flat cola. And they said that helped performance. So the dietitian, Greg Cox is a dietitian, he did some of the initial research to explore whether this actually helped their performance. And in the past, people thought caffeine was a diuretic. You drink caffeine, it'll make you go to the toilet more, go and pee. And that's not necessarily what we want, especially in endurance athletes. But the research, more recent research, obviously shows that even if you take a caffeinated drink, you'll still retain more water than you'll go into the toilet and urinate out. So yes, it is a small diuretic, but water itself is a diuretic. In this initial study, they showed improvement in time trial performance on the cycling at all levels, at all doses, sorry. So we use that information to start thinking about our own studies. And we did studies with carbohydrate, with or without caffeine, and we showed improvement in sprint performance and improvement in counter movement height. In this particular study, there was no difference in the passing skill performance. But as a result of some of this work, Lucozade Sport, they produced a caffeine boost drink, and then that was on the market for a wee while, but then it got taken off the market because of regulatory aspects. So why does caffeine work? How can caffeine provide an ergogenic benefit? Now, in the past, people said that some of the work by David Costeel and Foster and others in the late 70s, what they said was that caffeine, what that does is release more free fatty acids, and that free fatty acids potentially increases fat oxidation, saves the carbohydrate, and therefore you improve performance as a result. However, in more recent times, we feel that it's not the fat lipolysis that's the issue. It's more about caffeine's effect on adenosine. It's an adenosine antagonist. So at the blood-brain barrier in your brain, for example, we have these adenosine receptors. And what adenosine does at these receptors, it blocks certain sites in the brain, and therefore it reduces dopamine and glutamate. Now, these are important neurotransmitters that help us, like a rewarding type symbols, and it helps us when we it's like the party, have a party neurotransmitter, if you like, and that's dopamine. And what that does is encourage central fatigue, encourages tiredness, it reduces arousal, reduces performance. So adenosine, as you feel tired, as you feel sleepy, it encourages more of that tiredness, more of that reduce that arousal, and so on. So that's what adenosine does. But what happens with caffeine then? When we take caffeine, it blocks. Oh, I'll do that again. When we take caffeine, it blocks the ability of adenosine to bind onto these receptor sites. And what that then does is increase dopamine and increase glutamate. What that does is reduce the central fatigue, reduce the feelings of tiredness, reduces the feelings of pain perception, increases arousal, and ultimately increases performance. So that's why we think that caffeine does that. So obviously, from a carbohydrate perspective, plus adding to caffeine, could both of those have a really good benefit? You're providing fuel, reducing the pain and all the rest of it, and also making them feel better. If you can make them feel better, they're more likely to be more active. So that's the sort of thing we are encouraging then. What can we do to try and enhance performance by making people feel better and not just the fuel-related aspect? Some of our studies, we use the ratings of perceived exertion scale, the RPE scale, which I'm sure many of you will know about. Now, when I was doing my PhD, I was working with some of my psychology colleagues and another PhD student. We looked at these two other aspects of affect. What's going on in your brain, not just how hard you think you're working. And we use something called the feeling scale and the felt arousal scale to look at activation or arousal and affect. So how do you feel? Do you feel positive or do you feel negative, or how aroused do you feel? And from that, we can pick out this, what we call the circumplex model of affect. In a low activation pleasure state, you might feel calm. You might feel in a meditative state. You feel positive, but low activation. When you have low activation and displeasure, you might be bored or have fatigue, and you're not necessarily feeling very good about this low activation state. However, in a high activation displeasure state, you might feel anger, you might feel real pain, you might feel like you're in a highly aroused state, but in a negative way. And then finally, we have a high activation, high pleasure state. And that is, when you've exercised, sometimes you feel so good, you feel like you're not tired, you feel euphoric, you feel like you can do anything. And that is the state that we want to be in when we exercise, because it allows us to feel good and enhance performance as a result. We've done lots of research in this space as well. And here's one study that we did with female footballers. And here on the right-hand side in the placebo, A is before supplementation, B is after supplementation. Oh, sorry, A is before supplementation, B is at the end of exercise, C was the day after, 24 hours or 12, 15 hours after the exercise. So as you can see here, in a relatively neutral state in the placebo trial. However, in the caffeine trial, A here is before supplementation, B is at the end of supplementation, at the end of exercise, sorry, and C is the day after. So with the caffeine, they started off in a low, calm state, but then they went into this euphoric state during the exercise itself. This was not replicated in the placebo store. They performed better here in this in the caffeine trial as a result. So what caffeine does do then, on top of what carbohydrate does, is make you feel better. It reduces a sense of pain, and it can make you more focused as well. Here's some nice data from Sockman et al., which shows the different aspects of what caffeine does for people. If I don't take caffeine, I don't drink coffee. If I take now a caffeine pill, I take that, it will increase my mental alertness. It might increase my mood, but it'll certainly cause me some jitteriness, and it will reduce my tiredness, and it will reduce my risk of headache at that point. However, if I take caffeine, I know it will impact on my sleep, massively impact on my sleep. Whereas tolerance, someone who regularly has caffeine and then tries to have the same amount of caffeine for performance effect, they won't see much change. They won't see much change at all. By the way, in these colors, blue is good, red is bad, yellow is no different. For caffeine cessation, someone who drinks regular amounts of coffee or drinks quite high amounts of caffeine, and then you ask them to come off, this is the sort of problem that you can have with them. We have to be very mindful when we work with caffeine, where people are. Are they acute users? Are they regular users? Or are they high users? And if we want to use it for an ergogenic aid, we need to be appropriate. We need to design our studies appropriately, but also the intervention from a practical perspective, we need to design it appropriately so that we get the best benefit from that supplementation. Because if you give too much caffeine, it can become quite toxic, and that is not very good for anyone at all. With regard to caffeine, then, we have improved endurance performance in team sport performance, muscle endurance performance, lots of great benefits there. And why does this happen? There might be some metabolic effects, certainly neuromuscular, and certainly the CNS effects, the central nervous system effects on mood and pain. But we have to be also very mindful that when we take caffeine, it will impact on my sleep. If I take it as a supplement, I will struggle to sleep that day or that night. If I struggle to sleep, I'm not getting important recovery aspects. Therefore, my subsequent performance may be hurt as a result. The other thing, as I said, caffeine is an adjuvant, so it can speed up or slow down other drugs. So some people can take it with other things, and it can actually be very harmful for us. There's the withdrawal effects of caffeine. If you get habituated to caffeine, taking yourself off can lead to actually reduced performance, not enhanced performance. Also, we don't want caffeine in children. Here in New Zealand, the Ministry of Health says children under 13 should not be having any caffeine at all. And we don't want to necessarily teach our children behaviors that we don't really want them to carry on through unless they really need it. The other aspect of caffeine, and we've done quite a lot of work in this space, is genetics. Some people are fast metabolizers. They have caffeine and get rid of it quickly. Other people like me are slow metabolizers. It goes into my body and it slowly gets out. So therefore, that can harm my sleep patterns, for example. Or someone who's drinks caffeine and is a high metabolizer, they can get rid of it faster. So we're doing some work in this space as well. Other projects I'm involved in right now, and in the interest of time, I'm not going to spend too long on this. Beetroot juice, I mentioned to you before, we've done some work in cardiovascular health and beetroot juice, but also looking at performance in beetroot juice. We've worked with a company looking at blackcurrant and caffeine to see whether this can help football type performance. And we're still finishing off that student. I've got a PhD student doing that project right now. We're looking at various aspects related to children's drinking habits and what can we develop appropriate children's drinks through our beverage lab for athletes and also non-athlete children as well. We're looking at vegan type drinks because vegan protein is becoming more popular around the world, not just whey protein from cow's milk, but can we use other types of protein sources like pea protein or soy protein or almond and so on? Can we use that to help us create vegan protein drinks? We were looking at turmeric study and whey protein to help older people and performance of older athletes as well. And we've got a PhD student on that space. And other things like pickle juice. Could pickle juice help with cramp relief and so on? We've got a number of different types of projects that we do under our beverage lab project. And I've got several PhD students who are working on various things in this space, working with hypertension, working with diabetes, working with performance in older people, and of course, performance in athletes as well. So to summarize today's talk, to allow some time for questions, carbohydrate ingestion is more than just energy provision. I've shown you information about how it can help endurance performance. It can also help sprint performance. It can also help skill performance. And it can help with mood. It can help with reduced pain. It can also potentially help with reducing immune function or enhancing immune function following exercise. With caffeine ingestion, good evidence to support skill performance, sprint performance, endurance performance, and reducing pain and so on. And we see now that caffeine and carbohydrate together, they have individual and additive effects for performance. And that is something I'm keen to explore further in other cohorts, like in older people or people who are playing at recreational level of sport, plus people who are, women, for example. And I'd certainly like to explore not caffeine, but with carbohydrate in children as well. Whenever we do any supplementation, we always have to be mindful of practical issues. If you take caffeine straight away and you've never used it, you might have some bad effects as a result. So we need nutrition training for people. Your dietitian or your nutritionist would need to work with an athlete to help find what works for them. And also, if you don't normally drink carbohydrate drinks and all of a sudden you're starting to do it, it might give you some stomach problems, gastrointestinal distress. So we just need to make sure we're always mindful of what people can drink before or during or after exercise. And the other always very important thing to realize is there are individual responses and requirements for people. And this is the evidence for generic, but what works for you might be different. And that is something we always have to be mindful of. Okay, guys, well, thank you for your time. I really appreciate you listening in to me. And I'd like to open this up for any questions that you might have.
Thank you. Thank you very much, Professor Ajmol, for the very informative and insightful presentations. Let's move forward to the Q&A session. Has anyone in the Zoom has any questions, comments? Okay, this is a question from Pak Sulaiman. I'll read in Bahasa first and then in English, so everyone knows what the question is. He asked, bagaimana dengan masyarakat yang rutin berolahraga setiap hari? Apakah minuman berkarbohidrat dapat disarankan atau hanya diususkan untuk sport performance? Jika ya, apakah ada perbedaan dosis konsumsi? So, Pak Sulaiman asked about the consumptions of carbohydrate for low people, so for lay people. I mean, for public people, for people who are not in the sports, aiming for sport performance. Is there any recommendation for carbohydrate intake? How much for lay people to get a better performance for them?
It's a great question. It's a great question, Bustang. And hello, Suleiman. We've met before, so hello again. I think the thing with we're working, the people I've been working with are, some of them are international athletes and some of them are very high performing athletes as well. Whereas with lay people, they might have different requirements. I'd love to do some research on, can carbohydrate intake help reduce the glycogen depletion to some degree, that it can help with reducing illness in athletes, in lay people? And can it also help reduce the risk of injury, especially with old, I'm late 40s now, and I'm still trying to play football, but we have a very high injury risk amongst our population. So what can we do to try and help them, not necessarily from a performance perspective, but reducing problems like immune function, like injury risk, and so on? So I don't have the answers for all of that yet, but I'd love to do that research in that space. It's not about scale performance or sprint performance or anything. It's more about, can it help with health promoting behaviors while playing football, and potentially help with skill, but that's not the main focus. I'd love to do that research in the future.
Sure. Thank you very much for your response, Prof. Ajmol. Anyone in the Zoom has any questions? Can be in English or in Bahasa. Oh, there's another question from Pak Agung from PGRI Madiun University. He asked, Bagaimana mengukur kebutuhan kafein setiap orang? Karena setiap orang memiliki metabolisme yang berbeda. Misalnya atlet, orang yang suka berolahraga dan masyarakat umum. Apalagi atlet saat ini ada aturan anti doping terkait konsumsi kafein. So he asked, Pak Agung asked about how to measure the caffeine needs of people, because of course every person has the different kind of metabolism mechanisms, so they may different caffeine needs. There's a difference caffeine needs among people, and especially for the athletes. Now there is regulations about caffeine consumptions regulated in the doping policy. So how do we do that?
Very good, first thing. So I'll try and answer that in different stages. The first thing is we don't need caffeine. Caffeine is a pharmacological aid. We don't need caffeine to survive. It's not nutrition, it's a pharmacological agent. But if we're going to use it for athletic purposes, as I explained in one of the slides, we need to be mindful of each individual person. Now, there are various aspects of that. Habituation, if you take caffeine regularly, you get used to it. The metabolism aspects and the genetics part of things, okay? We need to consider what type of sport it is. We also need to consider how long before the sport is actually being performed. So there's a number of different facets that we need to consider, okay? Now, as I said in one of the slides, individual responses. This is the evidence across a number of people, but typically, for each individual, it will be different. So my recommendation would be take the relevance, take the information that yes, caffeine can be a good ergogenic effect, but it may or may not work for me. All the research I've done over the last 15, 20 years now, probably closer to 20 years, about 1 in 3 people do not respond to caffeine. So 30% of people do not show an ergogenic effect. 60, 70% do. So are you in that 30, 35%, or are you in the 60, 70%? Okay?
Okay, let me just summarize it in Bahasa, just to make sure that everyone understand what the answer is. Jadi jawaban tadi dari Prof. Ajmol bahwa pada dasarnya kita tidak membutuhkan kafein. Jadi di riset tentang kafe ini karena kafe ini menjadi sebuah habit atau kebiasaan. Banyak orang yang mengkonsumsi kafein di kehidupan sehari-hari, sehingga dilakukan ada risetnya, dan itu memang ada pengaruhnya terhadap metabolisme tubuh. Tapi pada dasarnya kita tidak butuh sebenarnya dengan kafein. Dari ada sekitar 30 sekian persen yang orang dia mengkonsumsi kafein dan itu tidak berpengaruh apa-apa ke dia, dan sisanya sekitar 60-70% memang ada pengaruhnya pada metabolisme tubuhnya. Okay, so the other questions from everyone in the chat, we have about and Prof. Aj, we have about 15 minutes for the Q&A session for this session. So please, if you want to ask directly to our keynote speaker, you can just unmute yourself and ask your questions either in Bahasa or in English. So question from Siti Sahara. So she asked, what caffeine mengganggu bagi apakah kafein itu mengganggu bagi penderita penyakit stroke? So she asked about whether caffeine intake could deter or affect people with stroke, a patient with stroke disease.
That's a very interesting question, and I've never come across that before. We are about to do a research study with stroke patients and looking at whey protein intake and exercise on helping them speed up their recovery and muscle function and so on. Now, I wouldn't know. To be honest, it's never come to my attention about that. I would be considering, could caffeine be involved in some of their pain medication, possibly, because it helps with the adjuvant aspects of pain management, but I would not know. And it depends on the level of stroke as well. So I can't really answer that anymore, but it's certainly an interesting question. Thank you.
Thank you, Prof. Jadi Prof Aj belum tahu jawabannya apa untuk itu karena belum meneliti tentang itu, belum meneliti tentang kafein untuk penderita penyakit stroke. Tapi itu mungkin dan sangat menarik untuk diteliti atau dilakukan penelitian tentang itu. Tapi Prof Aj belum pernah meneliti dan tidak tahu tentang itu. Next question from Ina Aprilia. Please allow me to read in bahasa first. Fenomena yang saya lihat di masyarakat, ada yang sebelum berolahraga mengkonsumsi pre-workout seperti whey, keratin dan lain-lain. Bagaimana menurut Prof? Okay. So she asked, there is a phenomenon particularly in Indonesia, Indonesian people, where they consume pre-workout substances such as whey or creatine and so on before doing an exercise. How about that? Does any research looking at this issue?
Yes, excellent question again. And caffeine, I said before, is an adjuvant, so it speeds up reactions. So what can do is lots of things go into pre-workout supplements. What caffeine can do is just help those
Okay.
help those reactions. Someone mute. Sorry. Okay. So yes, what caffeine? Sorry, I lost my train of thought. Can you ask that question again, Basta?
Sure. Sorry for the disruption. So she asked about the pre-workout substance consumptions before exercise.
Okay. One of the problems with the pre-workout supplements is there's so much in there that we don't know what the actual active ingredients are, because it's like you've got 10, 20, 30 things in there. Which is the one that's causing performance? Well, it might be one, it might be a combination, or it could be none of them. So caffeine is in most of them because it helps speed up the reactions for the others. So caffeine and creatine are probably the two, and whey protein will probably be the three most commonly used ingredients within a pre-workout supplement.
Yeah, so let me summarize in bahasa. So jadi jawaban dari Prof Aj, masalahnya pada pre-workout consumption atau mengkonsumsi substance pre-workout itu seperti whey dan keratin itu di dalamnya ada banyak sekali jenis kandungan yang berbeda-beda, ya, bisa 20-25 kandungan yang berbeda, sehingga agak sulit untuk melihat yang mana yang berpengaruh di situ. Mungkin saja karbohidratnya, mungkin saja kreatinnya, atau mungkin kombinasi dari kandungan yang berbeda tersebut. Jadi agak sulit melihat yang mana yang memberi efek karena ada banyak kandungan di dalamnya. Okay, before I also have a questions about your research. So I'm just curious about the carbohydrate mount rise, because you said, if I understand it well, you say that the carbohydrate mount rise is much more effective than the carbohydrate ingestions, even if you ingest it through the bloodstreams directly. Is there a research about a combination of those two methods, like you do carbohydrate mount rise first and then you ingest it?
So I showed you the detail in that study that I did with the 4 trials, the Latin square design with the cyclists. Some of them, they mouth rinse, spat out, and the other one, they same product or similar product, they mouth rinse and then basically swallowed it. Now, our research showed it was the ingestion which showed the benefits. In other studies, like many studies, as you know, Bostang, some show yes, some show no, some show no effect as well. So some people have shown carbohydrate mouth rinse has an effect, others have not. In our lab, we have not. In other labs, they have.
Okay.
And that could just be a responder, non-responder thing. Some people are more sensitive to certain things, like the caffeine I mentioned, and others are not.
Sure. So still like not very conclusive.
Exactly. It's not conclusive. It's not conclusive. It's not like caffeine, which most evidence shows that
Sure.
more people are helped or benefited by caffeine.
Sure. Thank you very much. Another question from participants from Pak Hasbunallah. Let me read in Bahasa first. The first question is, umur berapa seorang atlet bisa minum kopi? Dan yang kedua, berapa jam sebelum dan sesudah atlet latihan bisa minum kopi? So he asked two questions. First is, at what age does the athlete can drink or consume a coffee or caffeine?
Good question.
And then the second one is, how long in hours do we need to consume, the athlete need to consume caffeine before and after the exercise?
Okay, great. So here in New Zealand, it might be different in Indonesia. In New Zealand, the Ministry of Health does not recommend anyone under the age of 13 to drink caffeine, any caffeinated drinks. So it's about 13 and above here in New Zealand. There's evidence to say that the caffeine intake is increasing in children, and the research that we did with 1,300 sports people, some of them were drinking energy drinks like Red Bull or Monster or V or whatever they are. Okay, we would not recommend that. None of my research would recommend any of that. We've done research to show the harmful effects of caffeine on children. So I would not recommend that. I would not even do research studies on that because I don't think it should be done. What was the second part of your question? How long? Oh, sorry. Yeah, I do remember now. Yeah. So it depends. Yes, it depends. Caffeine, it can take about 1 hour, 60 minutes, 1 hour to get to the peak. Okay. So if your sport is 1 hour before the activity, that's when you should take it. Okay. However, you also have to think about when fatigue happens. A game of football is 90 minutes long, plus 15 minutes for half an hour. So about 2 hours. If you take it 1 hour beforehand, you might get benefit during that first half. But in football, you're most likely to have fatigue issues in that last half an hour of the game. So therefore, some companies are experimenting with having caffeine strips to put directly under the tongue, to have caffeine pills that you faster absorbing caffeine, and so on. So again, it depends on the type of activity, and it depends on the duration of activity. Will depend on when you should have it. The research says something for general, but then if I was an athlete, if I'm an athlete, or if I'm a nutritionist working with an athlete, I do individual experimentation with that athlete to see what is best for him or for her, rather than completely relying on literature. Okay.
Sure. Thank you very much. So let me just summarize the answer. So for the first question, kalau di New Zealand mungkin ini berbeda dengan di Indonesia. Di New Zealand itu ada aturan pemerintah di bawah Kementerian Kesehatan bahwa tidak boleh anak umur di bawah 18 tahun itu mengkonsumsi kafein atau minum kopi. Jadi itu dilarang. Jadi tidak akan ada riset berkaitan konsumsi atau meminum kopi untuk anak di bawah umur 18 tahun. Kemudian berkaitan dengan pertanyaan yang kedua, berapa jam? Pada umumnya reaksi kopi itu setelah dikonsumsi atau kafein itu sekitar 1 jam reaksinya. Jadi kalau misalnya dalam sepak bola, mungkin setelah mengkonsumsi kafein tadi 1 jam awal itu akan peak performance karena efek reaksi dari kafeinnya. Tapi setelah itu mungkin akan hilang. Jadi durasi berapa lamanya dan atau berapa banyak kafein yang dikonsumsi itu bergantung jenis latihan atau olahraga yang dilakukan, dan juga tergantung durasinya. Dalam sepak bola misalnya kan waktu normalnya 90 menit, ada tambahan 15 menit juga. Jadi kalau konsumsi kafeinnya hanya di awal tadi, maka efeknya tidak akan tidak akan bertahan sampai selesai permainannya. Makanya ada penelitian juga atau perusahaan yang mengeksperimenkan untuk mengkonsumsi kafein selama pertandingan. Jadi efeknya itu akan tetap ada sampai selesai pertandingan. Jadi tergantung jenis aktivitasnya atau olahraganya dan berapa lama durasinya. Okay, the next question is from Pak Suryadi Yusuf. Apa peran tidur dan pemulihan aktif dalam program latihan olahraga modern? Bagaimana hal ini diintegrasikan dengan nutrisi? So he asked, what is the rule of sleep and active active recovery in exercise program, in a modern exercise program? How this be combined with the nutrition?
Sleep is very important, Bustang. Sleep is a very important activity for us. The reason why, you'll all have heard of the fight or flight response. Flight or fight response. So we have the high sympathetic nervous system drive. Afterwards, it's tiring. Your body's had to do lots of things to be ready to fight or flight. Afterwards, we need to go through a rest and digest response. We need to recover the processes, recover all the things that have been challenged to the body. And sleep is a very, very important part of that recovery process. If you are not sleeping, you're not causing the recovery of muscle tissue, of blood, of organ tissue, of just the toxins that develop in the body. If something like caffeine, yes, it can help performance, but if it can then reduce your sleep, then you have to weigh up what's the benefit of the advantage of performance relative to the decrement in sleep. And again, I would say there are lots of different individual factors which impact on that. I've seen studies where, yes, your performance is improved, but they did not sleep at all that night. That's not very good at all for that individual. And if you take caffeine regularly, and the cumulative effects of sleep and recovery could lead to illness, injury risk, reduced performance, fatigue, chronic fatigue, and all the rest of that. So sleep is very, very important, and it should be one of the key fitness indicator, or not fitness, one of the key indicators from a nutrition and sleep and wellness perspective.
So, thank you very much for the answer. Jadi tidur itu sangat penting untuk kita. Jadi ketika mengkonsumsi kafein misalnya, itu ada efeknya terhadap tidur. Jadi misalnya kalau mengkonsumsi terlalu banyak kafein, Anda mungkin performanya menjadi meningkat karena pengaruh kafein tadi, tapi akan terkompensasi dengan mungkin sulit tidur yang mungkin bisa menyebabkan cedera ataupun malah jatuh sakit. Jadi itu harus ada pertimbangan khusus berkaitan dengan konsumsi atau substansi yang dikonsumsi kaitannya dengan tidur, karena tidur juga merupakan salah satu kunci utama untuk kesehatan tubuh kita, well-being. Jadi perlu dipikirkan berkaitan dengan khususnya berkaitan dengan kafein, karena akan berpengaruh terhadap durasi tidur maupun kualitas tidur seseorang. Okay, there's another.
Okay, Bustak, can we make one last question, because I have got a meeting to go to as well, and I'm slightly late. So make this the last question, and then I have to head off. Okay, thank you.
Sure. So I think this is the last maybe question. I think it's more a comment. So from our Ph.D, Prof Syahrudin, he said sebaiknya kafein dikonsumsi tanpa campuran gula atau dengan gula dalam hal ini untuk seorang atlet atau masyarakat umum, atau ada campuran yang disarankan. So he asked which one is best when consuming caffeine. Do we need to consume caffeine combined with sugar or without sugar? And is this a difference for people, for lay people, and for the athletes?
Good question. And some of our research then shows that the additive effects are pretty good. Caffeine will provide some performance. Carbohydrate will provide some performance. Together, they provide additive performance benefits. Okay, so they provide an additive effect.
So sorry, I didn't hear that.
They provide an additive effect. So one is good, caffeine is good, carbohydrate is good together, they're better. And that's what some of our research has shown.
Sure, sure. But not too much sugar, I guess. Right, because
good point. It's going to be an awful thing to say, but it depends. It depends.
Yes,
It depends.
sure. Ya, ya. So jadi jawabannya adalah karbohidrat, karena gula itu mengandung karbohidrat, dan kafein itu ketika dikombinasikan dengan karbohidrat, ya tentu bagus karena kafein, dari riset kafeinnya itu berpengaruh terhadap performance, begitupun juga karbohidrat. Jadi kalau dikombin ya tentu akan meningkatkan performa, tapi perlu diingat bahwa ada kadar tertentu yang itu harus dipikirkan, karena kalau terlalu berlebihan juga lebih ke negatif daripada positif untuk performance seseorang. So I think that's all. We are 10:20 now. We really grateful and saying thank you very much to Professor Ajmol for sharing with us some of his wonderful words within caffeine carbohydrate research. It is an honor for us to have him in this event. Thank you very much.
Thank you,
Ajmol for your sharing.
I'll see you again.
Thank you very much.
Assalamualaikum.
Yeah, see you again. Waalaikumsalam. Thank you very much.
Bye bye.
We give you a certificate to Prof. Aj for this event. Now we are waiting for the second speaker to join us in this Zoom meeting, and while waiting, we can take a break for about 5 minutes while the second speakers, Dr. Ayu Suzailiana Muhamad from USM Malaysia, to join us in this Zoom meeting. Thank you. Jadi kita sambil menunggu pembicara kedua untuk join di Zoom. So the second speakers will be Dr. Ayu Suzailiana Muhamad. She is the head of sport and exercise science program within School of Health Sciences, Universitas Malaysia in Malaysia, and she will be sharing with us about benefits of probiotics and exercise on immune function. So it's going to be about probiotics and exercise and effect on the immune function. So Dr. Ayu is with us now in Zoom. Hello, Dr. Ayu. Assalamualaikum. Can you hear us? Hello, Dr. Ayu. Assalamualaikum.
Can you hear me?
Yes, we can hear you now.
Okay.
Hello, Dr. Ayu. Good to see you again.
Hey,
How are you doing?
Alhamdulillah, I'm good. Thank you for having me today.
Alhamdulillah. Yeah, thank you very much for your kindness to share some of your work with us this morning.
You're welcome. You're most welcome.
So let me just introduce Dr. Ayu Suzailiana Muhammad, our second speakers for this event today. So Dr. Ayu Suzailiana Muhammad is a lecturer in sport and exercise program in the School of Health Sciences, University Sains Malaysia, and also the head of the sport and exercise programs within the university. She has published about 50 papers in national and international journals within sports science fields, within various topics, including exercise physiology, sports nutrition, exercise sciences, and other related topics. She has done her Ph.D. at Loughborough University within the School of Sport, Exercise, and Health Sciences in May 2013, and also conduct several research in the international reputable journals, such as the recent one is efficacy of exercise treatments for chronic obstructive pulmonary disease, a systematic review. The other one is physical activity levels and associated factors for health complaints among female university students during COVID-19 pandemic in Malaysia. Thank you very much to Dr. Ayu Suzailiana Muhammad for her kindness and willingness to share some of her work with us in this event today. It is an honor for us to have her in this event, and it is great pleasure to welcome her virtually in this event. Dr. Ayu, you will have about 45 minutes to discuss your keynote presentations, and directly after that we will have a Q&A session with the participants. So we aiming to finish your session about 12:15 p.m. There's no time difference between Makassar and Kota Baru, so that will be great. So without further ado, please let us welcome Dr. Ayu Suzailiana Muhammad to deliver her keynote presentation. Please, Dr. Ayu.
Okay, thank you, Dr. Gustav. I'll share my slides, okay? Can you all see the slide?
Yes, we can see your slide now. Yes, it works.
Okay, right. So, Assalamualaikum and very good morning to everyone. So first of all, I would like to thank Dr. Bustang and the team. Thank you for having me today. I'm very honored to be one of the speakers for this webinar today. So without further ado, let me start the presentation today. Okay, so the title is The Benefits of Probiotics and Exercise on Immune Function. So my name is Ayu. Yeah, you can call me Ayu. So I'm one of the lecturer in the Exercise and Sport Science program in University Sains Malaysia in Kelantan. Okay. So this is the outlines of today's presentation. Okay, we'll talk about probiotics and immune response, exercise and immune response, and lastly, the combined effects of probiotics and exercise on immune response. So first of all, let's see what is probiotics. So probiotic is also known as friendly bacteria, or sometimes we call it good bacteria. Okay, as we know, in our gut, we have good and bad bacteria. So probiotic is good bacteria. So according to WHO, the definition of probiotic is live microorganism, which when we administer it in adequate amount, it can confer health benefit to the host. So far, unfortunately, there is no optimum dosage established for probiotic injection to induce beneficial effects. However, the recommended dosage is between 2 to the power of 8 and 2 to the power of 11 colony forming units per day. So these non-pathogenic microorganisms can be found in fermented food. For example, yogurt, tempeh, cheese, cabbage, kimchi, milk, soy, and of course the probiotics drink. Nowadays, I think there are so many brands of probiotics drink, and I think the most famous one is Yakult, right? Okay, and in order to qualify as probiotics, so not all microorganisms are probiotics. Okay, there are certain criteria they need to achieve or fulfill to qualify as probiotics. Okay, so the first one is it should be able to be identified at the genus, species, and strain level. So we know the genus, species, and strain level of the microorganisms, and they have to be safe for food and clinical use. For example, it should not causes any diseases, so non-pathogenic microorganism, and it will not degrade the intestinal mucosa. It not carrying transferable antibiotic resistance genes, which can be harmful to the body. It not conjugating bile acids of the host, and it is susceptible to antibiotics. The third one is it can survive the intestinal transit, which means that it is acid and bile tolerant. The fourth one is it able to adhere to mucosal surfaces. And then next, it able to colonize the human intestine or vagina, and it produce antimicrobial substances. It able to antagonize pathogenic bacteria. It possesses clinically documented and validated health effects. So it should has lab tests, many lab tests, and properly documented and validated about its health effects. Then only it can be considered as probiotics. And lastly, it should be stable during processing and storage. So the established probiotics that meet all these criteria so far are from lactic acid bacteria, commonly Lactobacillus and Bifidobacterium species. The other kind of bacteria include Lactococcus, Streptococcus, E. coli, and also some of the non-pathogenic strains of E. coli and certain yeast strains. All right, so that's about probiotics. So let's jump into probiotics immune response. So to date, growing evidence support that regular consumption of probiotics can modify the population of gut microbiota. As I said previously, in our gut, we have good and bad bacteria. Let's hope that when we consume probiotics, it will increase the number of good bacteria in our body to enhance health of the host. Okay? So it is hoped that consumption of probiotics can modify population of gut microbiota and subsequently influence the immune response. So the mechanism of probiotics, especially in the inflammation, it can aid in the regulation of inflammation. So it has direct effect and also indirect effect. So for direct effect, probiotics can bind, binding with the innate immune receptors. So through this binding, it can trigger pathways that will cause production of cytokines, which can reduce the inflammation. For example, interleukin-10. Okay. The indirect effects is through it can boost the production of short-chain fatty acids with anti-inflammatory properties. And it can also increase the synthesis of antimicrobial peptides that can influence inflammation resolution pathways. And lastly, it can protect and repair epithelial barriers. So all these effects leads to reduce the inflammation. All right. Next, exercise. As we know, exercise is any bodily activity that enhance or maintains physical fitness and overall health and wellness. So this is the recommendation by WHO. Okay, about 100 minutes of moderate intensity, and at least 2 days per week we should do muscle strengthening exercise that target all muscle groups. So regarding exercise and immune response, so as reported by numerous studies, exercise regularly at moderate intensity improve immune response. But if you do prolonged and or high intensity exercise, it can suppress immune response. So in addition, depression of immune response is most pronounced when the exercise is continuous and it is prolonged, and the intensity is moderate to high intensity and performed without food intake. Okay, no food intake during the session. So all these factors lead to depression of immune response. Consequently, okay, depression of immune response lead to infection risk. Okay, because immune function relates with the infection risk. If our immune function is strong, infection risk is decreased. Okay. So the risk mainly for upper respiratory tract infection for athletes. Nevertheless, the suppression of immune response is temporary, okay, whereby it can return to baseline value within hours. But if the athletes have tight schedule training schedule, recovery may be not enough. Okay, so there are certain strategies nowadays proposed by researchers, which include nutritional strategies by having some supplements to help to recover. Right, so this is the J-shaped graph and inverted J-shaped graph. Okay, this is the J-shaped graph. So it shows you the association between exercise intensity and risk of URTI. So if you do moderate intensity exercise, risk of getting infection is below average. Okay, but if you do high intensity exercise and prolong, the risk of infection is above average. So on the other hand, because the relationship between immune function and risk of infection is, if you have, as I said before, if you have good immune function, risk of infection is decreased. So that's why this graph is the other way around, inverted J shape. Okay. So if you do moderate intensity exercise, your immune function is above average. But if you do high intensity exercise and prolonged exercise, immune function is below average. So there are a few studies support this graph. Okay, for example, a study conducted by Matthews et al. In 2002, they reported that regular performance of 2 hours of moderate intensity exercise per day associated with 29% reduction in risk of URTI compared with a sedentary lifestyle. Okay, this was an observational study participated by 547 healthy adults. Okay, this is another study, a study among 150 marathon runners. They reported that symptoms of URTI occur in 33.3% of runners compared to 15.3% of controls, those who did not join the marathon. So marathon is a prolonged exercise, right? So that's why the symptoms increase among the runners. And it was most common in those who achieve faster race times. So those who achieve faster race times means they run harder. Okay, the intensity is higher compared to those who didn't achieve faster race time. So that's why the symptom is most common in this group of marathon runners. Okay, this study found that immediately after intensive endurance exercise, total leukocyte increased 50 to 100%. Okay, however, it starts to decline to 30 to 60% below baseline levels within 30 minutes of recovery, and it remains low for 3 to 6 hours. Okay. But imagine if the athletes did not have enough recovery. So this back to baseline value might not be and see the effects of having high intensity exercise or prolonged exercise on the immune response. Okay, this is another study by Gillam et al. In 2014. Okay, participants perform a running exercise for 45 minutes at 70% VO2 peak, and they took saliva sample at pre-test, post-test, and 1 hour post-exercise. And as a result, the lactoferrin secretion. So lactoferrin is one of the antimicrobial protein, important first-line defense in the saliva. So usually entry of pathogen during exercise is through nose and mouth because of the breathing. So this is one of the salivary antimicrobial proteins. So it's very important. So this study found that lactoferrin secretion rate increased with exercise and remained above baseline 1 hour after exercise. So it supports the benefits of having moderate intensity exercise. All right, so after we discuss about probiotics, okay, relationship probiotics and immune response, and also the exercise and immune response. Now, it is very interesting to see if combination of exercise and probiotics can give better effects to immune response. Okay, so some placebo-controlled studies in athletes have indicated that daily probiotics ingestion results in reduction of the severity of symptoms and fewer days of respiratory illness. So a study by Gleason et al. In 2011 had examined the effects of daily probiotics, which is the lactobacillus bacteria. Okay, so supplementation for 4 months during winter training in 84 athletes engaged in endurance-based physical activities. So what they found is the proportion of participants on placebo who experienced 1 or 2 more weeks with URTI symptoms was 36% higher than those on probiotics. Okay, and the number of URTI episodes was significantly higher in the placebo compared to probiotic group. However, the severity and duration of symptoms were not significantly different between groups. And lastly, the saliva IgA. Okay, saliva IgA is also one of the antimicrobial proteins present in our saliva. It acts as first line of defense when there is entry of pathogen. So as saliva IgA concentration also higher in probiotic group. So as a conclusion, we can say that regular probiotics consumption is beneficial in reducing the frequency of URTI in athletes due to better maintenance of saliva IgA. Okay, this is another study by Salarkia et al. 2013. Endurance female swimmers were randomly assigned into 2 groups. Okay, the first one receiving 400 ml probiotics, and the other groups receiving ordinary yogurt without any probiotic as a control group. So they took this daily for 8 weeks, and as a result, it was found that this average number of episodes of respiratory infection in the intervention group was 0.6 day, which was statistically fewer than that in the control group. So control group 1.4 days, probiotic group less than 1 day. Okay, now I'll share some of results from my studies with regards to probiotic supplementation and exercise. Okay, so the first one is effects of lactobacillus probiotic on common cold infection incidence and mucosal immunity in endurance athletes. So actually this is my PhD study, okay, when I did my PhD in Loughborough University with Prof. Michael Gleason. So this is the method. It is a randomized double-blind placebo-controlled trial, and we have 267 student endurance sport athletes. They were randomly assigned to either probiotic group or placebo group. So it is double-blind, so they did not know what they received until end of the study. And this supplement or this drink was ingested twice daily for 16 weeks. So every week they came to the lab to take the products for 1 week. Subjects completed validated questionnaires on respiratory tract infection symptoms on a daily basis. So every day they have to do this questionnaire, which is only 1 page. And also they have to record their daily physical activity. Saliva samples were collected at baseline, okay, and at 4, 8, 12, and 16 weeks of the intervention. And then these saliva samples were analyzed for antimicrobial proteins concentration. We also took blood samples, okay, before and after 16 weeks of the intervention for hematological analysis. Okay, as a result, there was no significant difference in URTI incidence between both treatment groups, but the salivary immunoglobulin A increased in both groups, but it was significantly lower at baseline in PRO. And during URTI incidence, the extent of the reduction in training load was somewhat lower in PRO. So although both groups have same URTI incidence, but during the incidence of URTI, the extent of reduction in training load is not that much in the probiotic group. So as a conclusion, regular ingestion of lactobacillus probiotic tend to reduce the extent to which training was negatively affected when infection was present, and increase both saliva SIGA concentration and secretion rate over time, but did not appear to influence URTI. So we think that SIGA URTI incidence is not significantly different because SIGA was significantly lower at baseline in probiotic group. So when we start the study, SIGA is already low in the probiotic group. So if both groups have same level of SIGA at baseline, maybe we can see that SIGA in the probiotic group is higher than placebo and will lead to reduced URTI incidence in the probiotic group. So that's our speculation for this study. Okay, the next one is effects of 14-strain probiotic supplement on salivary antimicrobial proteins at rest and in response to an acute bout of prolonged exercise. So this time we use a multi-strain probiotic. So this probiotic has 14 strains. The previous one, only 1 strain, which is the lactobacillus. Okay, this is also one of my PhD study. So the methods, we have 11 participants cycle for 2 hours at 60% VO2 max on 2 occasions. The second trial was performed after 30 days of supplementation with a 14-strain probiotics. And the probiotics were in capsule form and taken as 1 capsule 3 times daily in the morning, midday, and evening. And then we took saliva samples at 3, post, and 1 hour post, as well as 2 hour post exercise. Saliva samples were analyzed for secretory immunoglobulin A, alpha amylase, lactoferrin, and lysozyme concentrations. So all these are the antimicrobial proteins in the saliva. So results, we found that 30 days of supplementation with the 14-strain probiotics did not alter salivary ANPs, okay, at rest and in response to an acute bout of prolonged exercise. However, prolonged exercise significantly increased lactoferrin concentration and alpha amylase activity post-exercise. So we think that supplementation period of 1 month is not enough to induce beneficial effects, because the previous study we gave them for 4 months. So this one we just give for 1 month. So maybe we cannot see the effects because of the supplementation period is not enough. And maybe the dose or concentration of the 14-strain probiotics used in this study were insufficient. Okay, because so far there's no effective dosage for probiotics, so we cannot say, but we speculate that the dosage is not enough. Okay, this is another study. So this is my master's student study. The effects of probiotic supplementation and circuit training on immune response among sedentary young males. So this time we give the probiotics to sedentary young males. Okay, the methods, we recruited 41 healthy sedentary males, and they were randomized into 4 groups. Okay, the sedentary control, probiotic groups, the circuit training with placebo group, and also circuit training with probiotic groups. So those in the EX, okay, and PEX groups, they perform exercise, which is the progressive load of circuit training, which involve 10 exercises with work to rest ratio of 1:2. So they perform this circuit training 3 times per week for 12 weeks. So these are the 10 exercises included in this circuit training. And participants consume multi-strain probiotics or placebo twice daily for 12 weeks. So this one is for group P and EX and also PEX. No, sorry. All 4 groups consume either probiotics. So for this probiotics P and PEX, they consume probiotics. For C and okay, only C with placebo and EX. Okay, C and EX consume placebo twice daily for 12 weeks. So for this study, placebo was prepared by the company that we approached, the same company that supplied us with these probiotics. And then we took saliva and blood samples, okay, at pre and post test. Okay, as a result, control group has no significance at all on all parameters measured. For exercise group, we found that there were significantly increase in most of the immune cells count measured. For probiotic group, we can see a significant increase in CD8 count and interleukin-10 concentration. And for combination of exercise and probiotic, okay, we also found increase in CD8 plus count. So, however, this study also found that there were no significant changes in salivary antimicrobial protein. So overall, 12 weeks of exercise alone, probiotics alone, and combination of these two are more effective than sedentary without taking any probiotics. Okay, we come to the end of the presentation today as a summary. So we can summarize that regular exercise at moderate intensity can enhance immune function. Probiotics consumption among athletes or physically active individuals might enhance their immune function and decrease the RTI risk. And hence it can improve their sports performance. And probiotics might confer positive effects on immune function, but we have to consider the effective dosage and duration of the supplementation. So these two factors should be enough, sufficient, so that we can see the positive effects of these probiotics on immune function. Right. Okay, that's all from me. Thank you very much.
Thank you very much, Dr. Ayu, for the very informative and insightful presentations on the benefits of probiotics and exercise on immune function. So let's proceed to the Q&A session. Anyone in the Zoom meeting could ask questions. You can ask questions on the chat, or you can just raise your hand and we'll allow you to speak directly to our keynote speaker. You can say your questions in Bahasa or in English. Anyone?
I understand Bahasa.
Yeah, Dr. Ayu is also understand if you speak in Bahasa. Anyone? So we have participants from students and lecturers from various departments. We have participants from Department of Sports Science, Department of Nutrition, the Department of Physiotherapy and Health Administration, I guess, in the Zoom. So here's the first questions from Pak Sulaiman. Berapa frekuensi konsumsi prebiotik yang disarankan untuk masyarakat yang berolahraga secara rutin? Jika ada dosis mungkin bisa disarankan. So he asked how much the probiotic consumptions or the frequency of probiotic consumption for lay people doing regular exercise.
Should I answer in Malay or English?
You can say in Malay as well.
Yeah, because the question is in Malay, so I answer in Malay. Okay.
So please.
So buat masa sekarang tiada guideline yang jelas tentang frekuensi probiotik yang disarankan. But berdasarkan research yang dijalankan, usually kalau athletes yang sentiasa bersukan, ada training, disarankan untuk mengambil probiotik setiap hari. So 1 bottle setiap hari, if it's a drink, 1 bottle, or if it's powder, maybe 1 sachet setiap hari.
Ya, jadi 1 botol 1 hari jika melakukan regular exercise. Okay. So that's the recommendation. Thank you for the response, Dr. Ayu. The other questions from Pak Agung Dwi Darmawan from PGRI Madiun University. He asked about circuit training. Bagaimana menentukan jumlah pos dalam circuit training? That's the first question. The second question is bagaimana menentukan lamanya istirahat dalam circuit training agar hasil latihannya maksimal. So the first question he asked about how to decide the number of pos in a circuit training. The second question is how to determine the long period of rest when doing circuit training so that the result can be maximum to get maximum result.
Ya, jumlah pos maksudnya jumlah senaman ke? Like in my study saya letak 10 jenis senaman. Itu kan maksud soalan ini? Jumlah senaman dalam circuit training. Is it?
Yeah, I think so, yes. Yeah.
Okay.
Yeah.
Okay. So basically apabila kita design circuit training, we have to look at the population yang kita include dalam our study. So like my study, it's sedentary population. So, but they are healthy. Okay, so that's why we go up to 10 kind of senaman. But there is usually we researchers put about 6 to 10 exercise. So you can play around with the number. There's no right or wrong. So depends on your population of study. And to menentukan berapa lama istirahat or rest period, this also depends on the population. If the population like for this study, for my previous study, I put 1 to 2. But if your population is patients, diabetic patients or overweight participants, maybe you can increase the rest period. And then after sometimes, maybe you can reduce. After they can adapt to the exercise, they become more fit, and then you can reduce the rest period. So there is no right or wrong based on your population, and as long as they can perform, they can complete the training, means that your design is okay, design is suitable for them. That's the main thing yang you kena aim. Bila you design, you make sure it can be completed to that certain population yang you involve dalam kajian.
Okay, I think that's the answer is quite clear. Thank you very much, Dr. Ayu. While waiting for the other question from the participants, we still have about 50 minutes for the Q&A session. I also have questions about your presentation, Dr. Ayu. First one is about the effect of probiotics on SIGA immunes. In your studies, you didn't see any effect of probiotic on a SIGA immune. That's because the participants already have a low SIGA immune before the intervention. So did you measure the changes on those two groups? Maybe perhaps the probiotic groups have a higher changes on the SIGA compared to the other groups. Can you confirm that?
The changes, yes. In the probiotic group, both groups have increase in SIGA, but the changes is most higher in the probiotic group, but no significant. So the trend we can see, the changes is higher in the probiotic group, but unfortunately it's not significant. So that's why we speculate the results with that.
I see. Sure. Thank you. The other question is about the comparison between the groups who do exercise alone and the group who do exercise and probiotic injection, a combination between the two. So in the result, it seems that the group who is doing exercise alone improve all the immune measure compared to the other three groups. Does it mean that doing the exercise alone is much more effective for the immune system rather than having a probiotic consumption?
No, I do not say that, because this is the single study from my study, one single study. We cannot conclude like that, because there are previous studies who said that probiotics are good. So maybe in my study, the supplementation is not enough, or because this is the multi-strains.
Sure.
Multi-strains studies using multi-strain probiotics is lacking actually. Usually, studies using one single strain like lactobacillus or bifidobacterium. So in my study, we use 14 strains, and maybe because of mixture of strains, we cannot see the effects. So I won't say that exercise alone is better than exercise and probiotics, but further research are required to
Sure. I see.
confirm this.
So it's not conclusive yet about
Yes.
the comparison. Sure. Thank you. There's another question from the participant from Ibu Dr. Arimbi. He said, She said, Assalamualaikum Dr. Ayu. Menarik sekali hasil penelitiannya terkait probiotik terhadap performa fisik. Apakah konsumsi minum probiotik ini juga perlu disertai konsumsi makanan prebiotik juga untuk optimalkan efeknya bagi peningkatan performa? Does it make sense to you, Dr. Ayu?
Yes.
please.
Because prebiotic is food for probiotic. So in theoretically, mungkin prebiotic plus probiotics more beneficial than probiotics alone. There are studies about this and mixed findings. Okay, some studies found positive effects, some didn't. But so far, I haven't get a chance to do combination of this probiotic and probiotic, but it is good to try out this kind of study later.
Sure. Jadi belum pernah dilakukan riset tentang itu ya, Dr. Ayu.
Saya sendiri belum, tapi previous study ada. But mixed findings.
Sure. Okay.
But theoretically, yes, we think maybe it will have benefits.
I see. Okay. Next question from Muhamad Dika Raswandi. He asked 3 questions. The first one is, apakah jumlah probiotik yang dihasilkan tiap jenis makanan seluruhnya akan diserap oleh tubuh? Yang kedua, berapakah jumlah maksimum probiotik yang dapat diserap oleh tubuh? Dan yang ketiga, jumlah minimal dan maksimal probiotik yang dibutuhkan oleh olahragawan or athletes.
Oh, this is hard question. This is regarding bioavailability of this product when we eat, when we consume, right? Okay. I watched one article about this because I didn't focus on this actually. Bukan semua tubuh lah. Bila kita makan probiotik, not all will be absorbed in our body. The range of absorption may be around 60 to 70% only. And I think I answered 1 and 2 already. So the third one is jumlah minimal and maximal probiotik yang dibutuhkan oleh olahragawan. This one also, no studies have mentioned about this, but as recommended, 1 bottle with 250 ml with 10 to the power of 11 CFU, colony forming units of bacteria, recommended to date.
Yeah. Is there any, I think you didn't mention this, is there any negative side effect of consuming probiotic for lay people or for athletes? Is there any research on that?
Okay. To my personal experience doing research on probiotics, I would say less than 2% reported side effects. And these side effects would normally just sakit perut macam tu saja. Tak ada yang serious lah.
Thank you, Dr. Ayu. We still have about 5 minutes. Let's further move to the other question. We have quite many questions on the chat. This one from Nur Latifa Mardianti. She is from Universitas Muhammadiyah Surakarta. She asked 2 questions. The first one, for your first study that you mentioned previously, what kind of placebo supplement that you use? Is there any different effects between different consistency, like liquids, semi-liquids, etc., and flavors like plain or versus flavor of the probiotics?
Okay, for this study, we approach Yakult company. So they provide us with Yakult with the probiotics and another bottle with same flavors, same bottles, same ingredients, except no probiotics. That's all. So we try to avoid all the bias and everything. So both look alike, only one bottle have microorganisms, probiotics, and the other one no. So the taste also the same. So they cannot, the participants cannot, didn't know what they took at the time.
See, thank you, Dr.
Another
Ayu.
question.
Yeah. Another question from Pa Abdurrahman. he said tempe sebagai makanan probiotik, bagaimana sebaiknya pengolahannya yang dianjurkan, digoreng atau yang lain, dan apakah ada perbedaan jumlah yang harus dikonsumsi sesuai dengan usaha dan aktivitas, apakah dia seorang atlet atau masyarakat umum. Does it make sense to
Yes,
you?
yes, yes.
Sorry.
Okay. I'm sorry, I'm not sure about if yang goreng lagi bagus ataupun rebus atau I'm not sure. But theoretically, these microorganisms, they are stable through the process. They should be able to be stable through the process baru dinilai sebagai probiotic. So I think this is through my observation and reading. I think goreng also can, the probiotic still there, but maybe the quality may be affected. But I'm not really sure, so maybe I have to search more about this. About perbezaan jumlah yang harus dikonsumi, because athlete they have training, okay. Masyarakat umum did not having any training, so like keperluan what we call it, carbohydrate, protein, and fat also different, right, between athlete and masyarakat umum. So for this probiotic also slightly different. Athlete maybe needs more because they have to fight more with the pathogen that enter through mouth and nose during the exercise to avoid any infection.
Okay, thank you. Thank you very much for the answer, Dr. Ayub. Anyone still have any questions for Dr. Ayub? If there is no more questions, or there is, I think this is the last question for this session from Pak Arfan Yakase. Saya lihat di berita negara Singapura menggolongkan minuman prebiotik seperti Yakult sebagai yang tidak disarankan dikonsumsi rutin karena memiliki kadar gula yang tinggi. Apa saran yang diberikan?
Okay, yeah, I'm waiting for this question juga sebenarnya. Okay, maybe yeah, because it has sugar yang agak banyak sebab sebab rasa dia tak sedap. It's a microorganism, right? So it's like the sugar can will added in to make it tasty. But I think Yakult dah ada yang less sugar punya kan? So maybe can consider that one, or can I think there's product. Yeah, I can't remember the name, but in Malaysia we can find it. Product yang tak ada sugar. I think it's in sachet. The powder, just consume like that. So there are so many choices. So kalau tak nak Yakult boleh choose another product yang ada probiotic juga.
So it's better to go for consuming probiotic drinks without sugar.
Yes, to
yeah.
avoid other health problem related to sugar.
Sure. But it's a one bottle taken regularly is okay. I mean, it's still in a recommended
Yes,
dosing.
yes. If the sugar level in the drink is kalau you risau tentang sugar level dalam drink tu, maybe you can cut your sugar intake from other sources, right? Because we are allowed to have certain amount of sugar per day, right?
Sure. Yeah. Oh, thank you very much, Dr. Ayu Suzailiana Muhammad, for a very informative, insightful presentation and discussions with the participants in this event today. We really appreciate your kindness, your willingness to share some of your work and experience in doing research in this topic with us today. Really appreciate it. On behalf of the faculty and the webinar committee, we are really appreciate your participation. Thank you very much. Please allow us to give applause to Dr. Ayu Suzailiana Muhammad for sharing with us today in this event. Thank you. Thank you very much, Dr. Ayu.
You're welcome. You're most welcome. Thank you.
We as a thank you to you. We provide a certificate as a keynote speaker for this event today. Thank you very much. Thank you very much, Dr. Ayu. I think this is the end of the keynote session. We are now nearing the end of the keynote session of the webinar today. Thank you very much to all participants, students, lecturers from Universitas Negeri Makassar and from other universities around the country for participating actively, involving in this webinar. Looking forward to seeing you again in the next webinar series, which will be running sometime in November this year. Before closing this session, we will take a photo documentation with all of you, including our keynote speaker, Dr. Ayu Suzailiana Muhammad. So if you don't mind, please, all participants, can you please turn on your video so that we can get a screenshot documentation for this event today. Thank you. We take first take. Second take. Third take. How many takes do we have? 5. Okay. Last one. Okay, that's all. Thank you very much. We have more than 100 participants early on from the first session till the end. That's really good. Thank you very much, Dr. Suzailiana Muhammad, and also the first keynote speaker, Professor Ajmol from Massey University, New Zealand, for their insightful and informative presentation and discussion in this event. We really appreciate their contribution, participation in this event, also for all students and lecturers coming to this event today. Looking forward to seeing you all in the next webinar series, series 5 in the next November this year. Thank you very much again. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Dr. Ayu. Thank you all. Thank you very much. Yeah, you may leave from the Zoom meeting, everyone. Thank you.
Thank you, Mr. Mustang.
Thank you, Igor. Thank you. Thank you, everyone.
Salam, thank you, everyone.
Terima kasih semua. Terima kasih Pak Bustam. Mas Sule, terima kasih. Sehat selalu semua.
Thank you, everyone.